Hi everyone, thanks for watching this video. Please do subscribe my channel by clicking on the subscribe button below. Please do give your like and comments on the video, and please make this video reachable to as many as possible by sharing it. So let's get started. So in this video we will see how do we perform joins using R. So we have the same data that we were using for SAS as well. We have data 1 and data 2. Data 1 contains product ID, category and quantity, and data 2 contains product ID and sales. So the joining key is product ID. So first let us see how an inner join is performed. For that we'll use the data set ex inner join, and we need to use the merge function for it. In the merge function we just need to pass on the data sets. So first my data set is data 1, second data set is data 2, and we just need to say my joining key. So the way we give joining key is using the by parameter. We just need to say by equals to which variable it is product ID, by product ID. And we'll just run this. See the output of this. So this is the inner join output in which we have product ID, category, quantity and sales. Now again in this, if we have a requirement that we only want category and sales, we don't want quantity, then we can again use the subset function and we can just have category and sales, or from in here also we can just directly use the subset function, and from subset function we can just say select equals to minus c, that is I want to drop quantity, so we can just drop quantity here as well directly. Now we won't have quantity, so we can use an additional function also with the merge function to get the required output. Now next join that we are seeing is after inner join, let us see full join. So we can just use the same query, and instead of inner join we'll just say full join. Here also we'll say full join. Let us remove this subset. So merge data, first data set, second data set by joining key, and then we need to say an additional parameter as all equals to true. The inbuilt parameter is all equals to, and we just need to set its value to true. Once we see the output, we'll have the full join output, wherein we have all the 10 products, and for P7, P8, we don't have sales because those are a part of data 1, and P9, P10, we don't have category and quantity because they are a part of data 2. Well, then let us see left join. So instead of full, let us say the data set name is left join. The only change that will happen is we learned the concept of alias in SAS when we saw the video of joins in SAS, wherein we for each data set name we just give an alias. Over here we'll just give an alias like this, x equals to y equals to, and over here we'll just say all dot x equals to 2. When we say all dot x, it automatically will understand that we are referring to data 1 data set itself, and we'll just run this. This will be the left join output, wherein we have a complete information for of product ID, category and quantity, and sales we don't have of P7, P8 because those are a part of data. Similarly, if we want to perform right join, so right join, let us give the data set name as right join, and instead of all dot x, we'll just say all dot y. We'll have the right join output, wherein we are having from P1 to P6 and P10 and P9 and P10. Now let us see the null joins, that is unmatched records, left null join and right null join. To see the unmatched records in R, let us understand one concept which is called row sums function in R. What exactly is that function all about? Let us say we have a sample data set which is ex1, wherein we have expense and increase. There is a function called as row sums. Basically, what it will do is it will give the summation row wise. So if I just say row sums of ex1, ex1 is nothing but the data set name. What it will do is row by row, it will calculate the summation. So it will be 1000 plus 10, which will be this entry, 2000 plus 20, which will be 2020, 3000 plus 30, and 4000 plus 40. That is how it will do the summation row wise. So we will use this concept and we will do the null joins in R. That is one way of doing it in R. Now also one thing to remember is in R, uh, if you can remember the SQL queries that we saw in SAS as well, the same queries we could had used through the SQLDF of package of R as well. But the only issue is all the joins cannot be done through the SQLDF. So that is the reason it is good if we ignore SQLDF package to perform joins in R. So let us see null joins. So first we will see the unmatched records. So we had this output of full join. Now from this output, ideally the task is wherever there are NAs, those ideally will become my unmatched records because there is no matching information for it for them in either of the data sets. So ideally the task, the way we will manipulate is we will try to pull up those entries wherein ideally there is an NA that is coming up after joining, so that those entries will be a part of unmatched records. To do that, we will utilize the EX full join dataset itself, which has the full join output, and we will put the dataset square bracket comma. So after comma, before comma is for rows, after comma is for columns. Columns we are not touching anything. We'll keep it as blank. Now for rows, what we will say is we'll use the function is.na. If there is an NA in the particular data set, so the data set is EX full join. Is.na ideally will give us the output in terms of true and false. So if I just run it individually, the way it will give us the output is in terms of true and false. So we can see everywhere there is a false over here because for all this the information was there. Wherever where there is an NA, the output is as a true because there were NAs over here. So we'll use this kind of manipulation. Now the internal coding of R, you can interpret false as 0 and true as 1. That is how you can interpret of how true and false are coded internally in R. So we'll just put a condition is.na is greater than 0. Wherever it is greater than 0, and to do that entire calculation of 1 and 0 in turn, we will just say over here do a row sums of this entire output. So we'll say do a row sums of this entire output and pull up the output where it is greater than 0. So ideally at the top of this we are using a row sums as well. Row sums greater than 0. So directly we won't be able to use it over here. That's fine. Over here we can just ignore it. Over here we'll just say row sums this is greater than 0. So now in a way what will happen is if this is interpreted as 0, let us assume this is interpreted as 0. So this will be 0, 0, 0, 0. So 0 plus 0 plus 0 plus 0 is will be 0. Similarly, this will be 0, this will be 0, this will be 0, this will be 0, this will be 0. Over here, when it will come, this will be 0, this will be 0, this will be 0. And this, let us assume that internal coding of R says it as 1. So this will be 0 plus 0 plus 0 plus 1. So the output will be 1. Similarly, wherever there is a true, at least the output will be 1. Over here also the output will be 1. Over here the output will be 2. Over here the output will be 2. So if we put a condition that in row sums, just pull out all those rows where s dot n is greater than 0, it will ideally only pull out this rows, because only for these rows the summation is greater than 0. So that is how we can manipulate it. Let us put this into a new data set, ex unmatched, and let us see the output of it. Sorry, row sums, s has to be capital, and we'll run this, and then we'll see the output. So now we are getting all the unmatched records, P7, P8, P9, and P10, which were the unmatched records from both the data sets. Okay, so the manipulation that we are using over here is we are trying to pull out those rows whose a total of row calculation wherever there is an NA will be greater than 0. Those are the rows that we are trying to pull out. Similarly, we can do the same for left null join as well. The same manipulation. If we try to do for left null join, let us put it into a data set left null. And this will be coming from left join data set. So we'll say left join data set. So from the output of left join itself, we are trying to figure out the null join output, which will be P7 and P8, which will be the left null output, which we had seen in Excel as well, P7 and P8. Similarly, for right null join, we can directly use this, and instead of left, we'll just say right, and over here as well, we'll just say right join, and this will be from the right join data. And this will be the output, which is P9 and P10, which was our right null join output as well, which is P9 and P10. So the way it is manipulated for null joins is using the concept of row sums, wherein first we are saying just figure out where there are NAs using s.na. After that, we take a row sums of it. So with the row sums, if we take an assumption that for false it will be the internal coding will be 0, and true, let us say if the internal coding is greater than 1, then wherever there is a true of NAs, those rows will be picked up from over here based on this condition, and that is how we'll get the output. So in R, the joins are done using merge function, and this is how all the joins are performed. Thanks a lot for watching this video.